If your code feels repetitive, it's probably asking for a function. Every application you use, from TikTok to YouTube to Google, runs on functions. They're basically little blocks of code that do one job over and over and over again whenever they're called. Think of a function like a reusable tool. You define it once, kind of like a recipe, and then you call it whenever you need it, and it's going to do that exact same process over and over again. Instead of copy and pasting code 10 times, you call a single function 10 times and it'll perform that task for you. Functions make your code cleaner, easier to debug, faster to scale, and all you need to do is change one line inside the function and it's going to update everywhere that that function is actually used. This keeps your code modular, saves you hours and hours of coding, and just make things that much simpler to read and scale whenever you need it. So whenever you hear someone say in the developer space, don't repeat yourself, what they technically are saying is, hey, use a function to keep everything organized, efficient, so that it's future proof and it's easy to scale. Every function is like a recipe, but a recipe isn't useful until you tell it what ingredients to use. That's what parameters and arguments are. They're how you pass data into the function so it knows what to work with, if you will. A parameter is just a placeholder, like a label on an empty bowl, which would be an ingredient. An argument is what actually fills it. So if your function says cook and you're passing in ingredient, then if you call cook and you pass in pasta, passing in the argument pasta is saying, hey, I need to do something with this pasta. Inside of that function, your code is going to use that value to run its logic, mix, calculate, transform, whatever it is that you need to do. When it's done, it can hand something back using the return statement. That's how data flows out of a function: input in, output out, clean, control, concise, easy to manipulate, and allow things to be much cleaner. So the next time you call a function, just remember arguments feed it, parameters define it, and return is going to give you that result. It's basically how functions communicate, like a message being sent, processed, and replied to, all within your code. If you've ever gotten undefined error and have no idea why, that's not your code being broken, that's scope doing its job. So scope is going to decide what parts of your code can be seen as variable and what parts can't. Think of scope like a house. If you declare a variable in the kitchen, you can use it in the kitchen, not the living room, not the bedroom, not anywhere else. In the coding terms, a variable inside of a function will be referred to as local. It only exists while that function is actually being ran. A variable outside of a function will be considered global. It's visible everywhere, but it can get very messy, very easy, and very fast. That's why most developers keep variables local, which is going to help it be clean, predictable, and then safe from name collisions as your application scales. So the next time something's not defined, check the walls around the variable, because scope isn't just about visibility, it's also about control and to make sure that you keep things aligned as your code continues to grow. Some functions are predictable, they always return the same thing. Others are going to be a little more moody. They depend on an outside variable or a change with something else. That's the difference between pure and impure functions. A pure function is going to always give you the same output for the same input, and it doesn't touch anything outside of itself, like add. And if you pass in two parameters, two and two, it's going to always return four. It's simple, it's testable, safe, easy to use, right? A impure function is going to change something. Maybe it writes a file, updates a variable, or logs something to the console. Those side effects, if you will, make it much harder to predict. So just remember, a pure will be predictable, impure will be powerful but risky. You can use both, they both serve a purpose. Just kind of keep in mind when you need to use what and kind of understand the definition of it and how it works. Everything comes with a side effect, everything has a cost. Just make sure that you're using it the right way so that you can have great architecture and a great end user experience. So you've heard of functions that do things, but what about functions that control other functions? That's a higher order function. And it's one of the most powerful ideas in modern code, if you will. A higher order function either takes another function as an argument or it's going to return one. So for example, in JavaScript, the .map function takes a function and applies it to every item in the array and gives you a new one. That means your logic remains flexible. They can swap behavior without rewriting the structure and makes things a lot easier, and you could be a little more creative with things that you can do. Functions can become reusable blocks of code, not just actions, but strategies, if you will. So the next time you see map, filter, or reduce, just kind of know that you're not just writing code, but you're using a function to kind of orchestrate and control other functions. That's what a higher order thinking or a higher order function actually does.